Alright, so this video is going to take you through an introduction to variables. This is our first day talking about variables for chapter 2. You should have page 1 of your notes here. And the other thing you need to make sure you have, because you'll want to do this in JGrasp as well, is you need to start a JGrasp document that has this class header and the main method header, of course, and then all 4 braces. So make sure you do that. If you need to pause the video and then come back, that would be great. And so what we did is we started talking about the computer memory first. Now, if you'll notice that I have a bunch of cups on here, and I want to get my little pointer. There we are. And so so notice we have our cups over here. So imagine, I did have this. I had a bunch of cups on one of the tables in VPC 101, and so there were, I mean, almost filled the entire table. And so that is a representation of the computer memory. And so what we did, let's see here. So what we talked about here is that the computer memory is the storage space in a computer. It's the storage space in a computer. It's divided into a large number of small parts called cells. And I should have gotten a picture of that. Forgot about that. But anyways, it's divided into a large number of small parts called cells in the computer memory. It's what's storing everything. Now you can look in different parts of your computer and find out, well, how, especially on the C drive, if you're a Windows machine. I'm not sure how you do it in Mac, but you can find out how what is the storage capacity of your computer memory. So how much can your computer store? Well, this is our computer memory right here. Were all the cups that were sitting on the table. And before we got to step 2 here, I asked somebody or I gave the students a post-it note and a starburst. And so I had someone, let's say Kate, it might not have been Kate, but I had somebody ask another student, let's say Kate. I had Kate ask her neighbor to go put her starburst in Kate's cup. And then the student said, well, how's she going to know where to put it? How's she going to know which cup to put the starburst in? And I said, well, why? What's the problem? And she goes, well, there's no name on the cups. And so that is a critical issue here, is that she did not know where to put the starburst because all these cups, they're not named. And that's the way their computer memory is. It's not named. They're just sitting there waiting to be named. And they're empty, waiting to be named. And so what happens is, then what I did is I had everybody take their post-it note, and on the post-it note they're supposed to write their name, and then go to the cups on the table and reserve their own cups by putting their post-it note on their cups. And so they did that. So let's just say Kate did hers. Let's say she put it here. Alright, so now we have a memory location that has a name on it. Well, a variable right here, a variable is a named memory location. So a variable is a named memory location in the computer memory. And so, for instance, here this is showing 6 of the cells in the computer memory, let's say, and well, I'm sorry, 12, but only one of them is actually a variable. Only one of them is a named memory location. Now the purpose of variables is to store data that can be used later in the program. So the purpose of a variable is to store data that can be used later in the program. Now, normally in a cup, you would pour a drink, and I was going to have them put a starburst because it'd be easier to do. But let's say that Kate labels her cup, and then she poured some kind of a drink in there. Well, she wouldn't pour the drink in there just to sit there and then she walks away and just never ever drinks it. The purpose is that eventually she would drink from that cup that has her name on it. And that's what happens with variables. So a variable is a storage location. It's named in the computer memory. Now, when you deal with naming a variable, you want to start with a lowercase letter. So start with a lowercase letter, where in classes we started with an uppercase letter. And then also we want to make sure that we use Camel Casing. And so here's some examples. So the second thing is Camel Casing. So example would be let's say games. That would be an example. Another could be num of games. And notice that this uses Camel Casing because each letter is capitalized. Each word is capitalized, of and games. And then it's lower Camel Casing because it's lower because it starts with a lowercase letter. And you want your variables to be descriptive, short as you can, but descriptive of what you have going on. So really games would not be as good a variable as num of games, because games could mean num of games. It could be games in season, so games last week. It could be different things. So you want to make sure it's a little bit specific as to what you're actually going to store in there. And so anyway, so that's variables. And then we come to data types. Now if you notice, well, I'll mention that later. The data type of a variable must match the data being stored. So the data type of a variable must match the data being stored. So we talked about ints and doubles in day 2 of this week, and so those are data types. And so if you're going to say the data type of a variable is an int, then that means you're going to store integers or positive or negative whole numbers in it. So it needs to match what kind of data is going to be stored in there. And so then there are 3 data types that we're going to use. And so we're going to use an int first of all, and that's a lowercase I, int. So int, the purpose of ints is to store, or an int is an integer, is a positive or negative whole number. And that's something you should be writing down. Make sure you get that down. Then you have a double. And remember we talked about doubles on day 2, is that a double is also D for double, D for decimals. So a double, a data type, stores decimals in it. And then the other one is called a string with a capital S. And so that's another data type. And so a string variable, as opposed to an int variable and a double variable, stores strings. So it's going to store, its values are going to be strings. Okay, so they'll be within quotation marks because they are strings. So this is a string, lowercase string, which is a part of a string variable. That's the data type. Because it's a class, it's kind of different, and it's capitalized. All right, now data types determine the size or the storage capacity of the cell, the data type. So when we start talking about declarations here, if you can declare it to be an int or a double. Well, what happens is the main point down here is that doubles are larger than ints. Doubles are larger than ints. So you see here is we have the red cups are larger than the blue. So the larger cups, the red cups would represent doubles, and the blue cups would represent ints. And you'll see how this is important later on as we go on. Alright, so then what we did is, and I don't remember if I said this yet in this video, but then we had the students go over to the table and put their names on here, the post-it notes on their cups, so that they would declare their names. I think I did tell you that. And so this is what their action of walking over to the cup and picking out a cup and putting their post-it note on that to name it is called a declaration. So when you write this line of code, in this line of code, a declaration has a data type and a variable name, so which we've already talked about both of those. So here's an example of a declaration. Oh my word, can't believe that. And so where did it go? And so this line right here is called a declaration. This is something that you'll write or type in your JGraphs type thing. So it has a data type, which is an int, so it's going to refer to smaller sized cells, and its name is num of cats. So it's like the computer, the compiler goes into the computer memory and sticks a post-it note on one of the cells, and there's millions of cells in there, and it picks one and it puts the name, assigns the name num of cats to it. So now it's a named location. And so what you can do then is then in your JGraphs you need to go in there and write, make a line comment that says declaration reserves named memory location, because that's what the compiler does, just like when the students went and reserved cups on the table by putting their names on them. And so, and then type your declaration here. And then when you do that, come back, maybe pause your video, and then we're going to go on here. And so now what happens is this code, you may think, well, it doesn't do anything. If you were to compile it, nothing would happen. And that's because this is all taking place inside the computer, so there's no output yet. But inside your computer, this line of code causes the compiler to go to the computer memory and reserve and name a particular location. So I forgot to put this in here. So this, we would say that this line of code reserves a memory location or a storage location in the computer memory by naming it. Okay, so that's what happens with the declaration. Now, the next thing I did is I had the students then walk over to their to the cups and find their name and put the starburst in there. And so that act of storing a content in the cell or a storage location is what we call assignment. And so an assignment, when you want the compiler to assign, when you want to tell the compiler to assign something to a value to a variable or to store contents in one of those memory locations down there, then you type the name of the variable, and then you put what we call an assignment operator, and then a value, and then the semicolon. And so so this right here, we don't call that an equal sign. It's called an assignment operator, right? So assignment operator, because it operates an assignment. It operates the storing of the 7 inside of this memory location. So what we would say then, it stores a value or contents inside of a variable, which is a memory location. Alright, so that's what the assignment does. So go to your JGrasp then, and in here we want to do a line comment that says assignment stores content in a variable or in variables, and then type num of cats is assigned 7 and then the semicolon. So we don't, by the way, just note of interest, and this is something you might want to write on your notes, is we don't read this as num of cats equals 7. We say num of cats is assigned 7. That's how we read it. Alright, now again, nothing is being printed or displayed. All this is going on inside the computer. And so then what we do is then we, now I was running out of time, so what I did is I went over to the table myself and went to Kate's cup, and I pulled out the starburst to give to her. So that's a call. So this num of cats, the name of the variable, is used to call for the contents of it. Okay, so the name of the variable is used to get its contents. And so what happens is, so I walk over to the cup and get the starburst, and then the terminology, and you want to make sure you write this down, the terminology is then I returned the starburst to Kate. And so it's called a return value because the compiler is actually going to the computer memory, to the memory location, taking the contents and returning that value to where its name is here. So what happens is then this num of cats is 7, the contents are 7, so write a 7 above num of cats. So that value is returned. So when it prints, when the compiler prints, it's not printing num of cats, it's printing the contents of num of cats. So it's printing a 7. And what I'd like you to do also is down here is to write variable call, because that's what that is. This is the name is being used to call the variable. And then the last thing is here is to go to JGrasp and type in the rest of this and then compile it and run it, and then you'll see the output, and you'll see that what happened in the background in the computer memory is then brought out to the front when it's printed. Alright, and so that's it for this particular video.